Hello, this is Xinru. In this video, we're going to take a look at question 572, subtree of another tree. In this question, we are given two non-empty binary trees, S and T, and we have to check whether tree T has exactly the same structure and the node values with a subtree of S. So we have to determine if tree T is a subtree of S. And how do we define a subtree? So a subtree of S is a tree consists of a node in S and all of these nodes' descendants. So we have to emphasize this sentence, and it says all of these nodes' descendants. So it should be until we reach the end of the subtree. So it should be until we reach the leaf of the tree, and the tree S could also be considered as a subtree of itself. So this statement means that tree S and tree T can be the same, and if they are the same, we still see tree T is a subtree of tree S. Okay, so now we look into examples. So you can see tree T 412 is a subtree of tree S 412 here. So return true. And here tree T 412 is not a subtree because it has to reach the leaf. So the leaf is 0. Therefore, it's not a subtree. So how do we solve this question? So first, to determine if a tree is the same, has the exactly the same structure of a subtree of S, we need to write a function that to determine both trees are the same. So this is the first recursive function we need to write. So first recursive function, we need to determine we need to determine a given two given trees are same structure. And the second recursive function, we need to go through different nodes. We have to visit different nodes in our tree S, and we need to fit different subtrees in tree S. We need to compare different subtrees in tree S and tree T in our first recursive function. So okay, let's get into coding. So here first I write a function isSameTree, and I pass in two trees. And so first I have to determine if tree S and tree T both not exist. So if this recursive function traverses to a node that doesn't exist, so traverse to the end of the node, then we would say if S not exist and T not exist, we just return true because both tree not exist, so we say they are the same tree. So and next, if one tree exists and another not exist, then we just return false. And the last statement is that if the value of, so if both tree exist but the value, if both nodes exist but the value of both nodes are different, then we see the tree is not the same. So we say s dot value not equals to t dot value, we will return false. And if both tree exist and their value is the same, then we can see at this time the node, we compare the node. At this moment, both tree are the same, but we still need to check the left node of the current node we're visiting and the right node of the current node we're visiting. So we're going to return the value of tree of the left node of the current node and the right and the left node, and we need to make sure the left nodes of both tree are the same and the right nodes of both tree are the same. So after we write this recursive function, now we need to so this recursive function can determine if both tree we're given are the same, are exactly the same. But now we need to go through different subtrees in our tree S and use those different subtrees to compare with our tree T using this recursive function. So what we will do is first we write the boundary conditions. So first if both tree not exist, then of course we return true, and if one of those trees exists, we return false, and then if then we call this function, then we call this recursive function and compare the current S and T, or we will find a different S and T, then we call the function itself, we call the recursive function itself, and then we call the left node of S of the current node we are visiting using our recursive function, using our second recursive function, and compare with T, or is subtree of S dot right, so the right node, and compare with the T. So let's submit the solution. Is same tree here. Okay, so the most important thing here is we need to find out the changing, we need to find out different we need to find out the nodes we have to visit. So first we have to visit all the nodes of the left subtree and the right subtree to compare both tree, and second we need to visit all the nodes in tree S so we can get different subnode and compare with tree T. Therefore, we need two recursive functions. So the first recursive function we compare to tree, and the second recursive function we can visit all the nodes in tree S and use the first recursive function to compare those subnodes and tree T.